So the Antarctic shot up at the middle of July, way above anything that we've been seeing, apart from the past 2 or 3 years. So last week, in some regions, the Antarctic, which is in its winter, was 28 degrees C above normal for that time of year. That is an absolutely stunning situation.
Hello, everyone, and welcome to another Climate Emergency Forum. My name is Regina, and I'm your host as we discuss chaos in the cryosphere and what chaos there is. Let me tell you, we recently did a show, Smoking Hot Summer, and it is smoking hot in the cryosphere. Unbelievably so. And this has great import for us. There's a saying, what happens in Vegas stays in Vegas. And I know my colleague Paul likes to use the casino metaphor to talk about the climate casino. But let me just say that what's in the Arctic, the Antarctic, what's in the cryosphere does not stay in the cryosphere. Many people make fun of climate activists, climate scientists. Oh, all they care about is those polar bears. What does that have to do with me? Well, it has everything to do with you. It has everything to do with everything. If they can't survive there, how can we survive here? I want to share something with you. I just recently took a cross-country trip. I drove with my mom from Texas to California. Okay, it was definitely a fuel mileage economy car. Okay, I want to point that out. But I also want to point out that the heat was tremendous. I'm a person who loves the heat. I can't stand being cold, but I've never experienced so much heat in my life. And I have to tell you, for our viewers in Arizona, this is no shade, but honestly, if the only way you can live in a place is to air condition constantly, is that place really livable? I have to ask this. I was just astounded. The way we're treating this planet is just simply not responsible. It's not responsible. I saw I-10. Did I see monorails being developed? No. More lanes of highway, more lanes of highway, more subdivisions, more houses, more cars upon the road to go further out of the city centers to everyone's little mini Terra. And listen, I understand people like to have big houses. I get it. But it really brought me down to see the direction that my country is going in, building more roads for more cars, for more emissions, for further warming the planet, and of course, the cryosphere. Peter and Paul are going to talk specifically about the cryosphere. I just want to bring to mind the general situation that we're in. And I want to talk about overshoot, that is climate overshoot. And I also want to talk about the climate clock because I'm a New Yorker and there is this clock. It used to be actually a really popular record store many decades ago. It was a really cool place. But of course, no one buys records anymore. There's a sign downtown that has, I'm sure you've seen the clock with the national debt. This is a clock that shows how quickly we're approaching 1.5 degrees of global warming. And as we're moving closer and closer and closer, one wonders, is anyone looking at this clock? Is anyone looking at the climate clock? And does anyone understand how desperate things are getting? So when we talk about overshoot, that means how much we are going to get over 1.5 degrees, or rather, how soon we will get to over 1.5 degrees, which was our goal, right? To keep the planet sustainable. And I just want to read a few things to you because we have this nifty website and we'll share the URL in the description. They list countries that if everyone lived the way these particular countries live, how quickly we would overshoot that goal. In 2024, if everyone lived like Qatar or Qatar, we would hit overshoot on February 11th, 2024. That's already passed. That's already done. That's already gone. It's really scary. What I found really interesting is number 2 on the list was Luxembourg. How is that even possible? It's such a tiny, tiny country. But if everyone lived like the people do in this country, we would overshoot on February 20th, 2024. Also, already in the past. Now, I understand number 3 on the list is the UAE, United Arab Emirates. Number 4 is Kuwait. And number 5 is Bahrain. But number 6 is Estonia. So you see, when we have countries that have a higher standard of living, people tend to disregard how detrimental their lifestyle is to the rest of the world, to the rest of the planet. There's little thought that, gee, should I run the air conditioner even though the doors to my house are open? These are things that we really, really need to think about because we are heading for overshoot, my friends. I understand keep 1.5 alive, but now it's time to get real because we're headed to overshoot. It will definitely impact the poles, and I want to turn it over to Peter to tell us all about that.
Thanks, Regina. We've been talking about overshoot for many years, and we have really overshot ourselves now. We've practically been at 1.5 degrees C for 13 months. It was at 1.5 degrees C for 12 months. Last month was 1.48 degrees C. So we're stuck at and over 1.5. The average temperature increase for the past 12 months is 1.64. So that's way over 1.5. So therefore, at and above 1.5, of course, we've seen unprecedented heat waves, particularly in the Northern Hemisphere, again this summer, this year, unprecedented forest fires, particularly in California, but also in the Canadian Arctic, again, not as bad as last year, but they're going to be the second worst ever compared to last year. But we have also brought about an absolutely stunning, unprecedented, unheard of situation affecting both poles of the planet, the Arctic and the Antarctic. The scientists have said for a little while this year, we are beyond, we're off charted territory. Well, that's certainly an understatement. So the Antarctic shot up at the middle of July, way above anything that we've been seeing apart from the past 2 or 3 years. So last week, in some regions, the Antarctic, which is in its winter, was 28 degrees C above normal for that time of year. That is an absolutely stunning situation. But not only that, it's been above 10 degrees C for at least a couple of weeks now. Now, it's never done that before. It's shot up 30 degrees C in 2022 in March, for example. But we have this superheated in the winter, still frozen solid, but this superheated Antarctic, which has run for a couple of weeks and it looks like it's going to be 3 weeks. That's completely unheard of. I didn't know. Paul Beckwith just told me as we're coming on the line here that the similar thing is happening in the Arctic, which is in the summer. So apparently the Canadian Arctic is up to 30 degrees C or something also unprecedented, unheard of right now. Now, I think anybody can understand that the vast expanse of the North Pole Arctic sea ice and the vast expanse of the Antarctic continent cools the planet. We're heating up the planet enormously right now. As I say, we're 1.5 C and above. And now our heating and our non-response whatsoever to that heating is bringing down both poles of the planet. That's a situation in which we should be very, very worried about the entire planet, the entire biosphere crashing. because the loss of these vast expanses of ice changed the climate completely. So Paul will be able to explain better than I why the Antarctic is superheated. But the Antarctic temperature has been increasing, slowly increasing for about 15 years. It's on a rise. The sea surface temperature of the Southern Ocean, which goes right around the Antarctic, that's elevated, that's high. The Antarctic sea ice a few years ago completely changed. The Antarctic sea ice sort of hadn't been changing, so nobody was worried about it too much, I guess. But starting about 8, 9, 10 years ago, we started losing Antarctic sea ice. And today, the Antarctic sea ice is almost at a record low. It's refreezing, but it's almost as low as it was this time in 2023. My final comment will be that 2023 was a huge record for global temperature increase, which stunned and shocked the scientists. Well, everybody is stunned and shocked now because 2024 is going to be even harder than last year. So we're way off charted territory. The models, the scientists, they say they're baffled. Sure. But what this means is that if we're going to have a chance of saving our planet, we have to respond now with everything we have got. I've been repeating over and over that the IPCC has been telling us for several years that global emissions have to be put into decline immediately. So this is actually this Antarctic situation plus the Arctic situation is yet another stunning, unprecedented shock of what's happening to the climate system. That's sort of it for me. I'm totally shocked. My colleague and friend Paul Beckwith will be able to fill you in on the fine technical details on various reasons why this could be happening, unprecedented events unheard of.
So I'm going to step back a little bit. Let's talk about some of James Hansen's work. Up to 2010, global average temperature was rising about 0.18 degrees Celsius per decade. After 2010, that greatly stepped up a notch to double the rate, at least 50% increase in the rate to double the rate. So he projected something like 0.18 per decade, going up to between 0.27 and 0.36 degrees Celsius per decade. And we're closer to the latter, to the greater rate, we're over 0.3 right now. And that's a big switch. And there's many reasons for that, which he discusses in his letters. But the important thing to remember is that we don't get uniform heating on the planet, far from it, right? There's a phenomenon called polar temperature amplification, or the cryosphere, right? Is at both poles, cryogenic temperature amplification, where the rate of change of temperature rise is far, far greater at the poles. That applies to both the Arctic and the Antarctic. In fact, in about the last 3 or 4 decades, the Antarctic temperature rise has exceeded the global average by a factor of 3, roughly. The Arctic depends on how you're defining those regions, but it's basically, most people, scientists would say, the increase in the Arctic temperature has been 3 to 5 times faster, even 7 times faster than global average if you go to the high Arctic. So we're getting a very non-uniform heating. And of course, the air circulation and the ocean circulation depends on temperature differences between different regions. So as we get huge warming in the Arctic, the jet stream slows down and becomes wavier, and those waves extend far in the north-south direction, right up into the North Pole, in fact, bringing huge amounts of warm air up to the Arctic. And also the same thing is happening in the southern hemisphere. Not quite to the same extent, because the Antarctic circumpolar circulation, both in the air and oceans, is stronger because there's no land masses in the way. If you think of the geometry of the Antarctic, right, the ocean can swirl right around. Antarctic is an isolated island continent. So we're seeing huge temperatures above and beyond anything scientists would have expected, both for Antarctica, which is right now in its winter, right? Southern hemisphere is in their winter. Northern hemisphere, where most of the human population lives, is in its summer. We're getting record temperatures in Antarctica. In fact, temperatures in some places are 50 degrees Fahrenheit warmer than they normally would be. I mean, that's what, 28 Celsius, something like that. Very, very warm temperatures, but a key factor is those temperatures aren't going above zero for the most part. So we're not getting huge ice melt as a result, but we are having huge effects on ice loss, calving on coastlines, because warmer ice is softer, it's more pliable, it's less likely to hold together. We're in the Arctic summer, of course, now. Inuvik is north of the Arctic Circle. It's very, very far north, just south of the coastline of the Arctic Ocean. For the last few days, temperatures there have been higher than temperatures in Florida. So we're talking about temperatures of 30 degrees Celsius. Multiplied by 9/5 and add 32, I think 30 degrees Celsius works out to 86 Fahrenheit. Right up in that far northern place. So people are, the people there are all wondering what's going on. Why is it so warm? And of course, Antarctica is much less inhabited than the Arctic. So although the temperatures are very high, it's not people that are seeing those signs unless we're talking about research scientists on the ice. We're having wrenching, profound changes to not just the rate of warming on the planet, but the way that the heat is distributed on the planet. And it has enormous implications. And if this is happening now, what's it going to be like in, say, a year, 5 years, 10 years?
Thank you, Paul, for leaving us with that thought. I mean, what is it going to be like in 5 years? Things are changing so rapidly. It boggles the mind. It's so hard to keep up with it. It's so hard to assimilate what's happening. And of course, we have the positive feedback loop. So as the ice melts, there's less albedo, which encourages more warming, which encourages more warming. So, I mean, sometimes I wonder, are we going to be on a runaway freight train soon? It's a really scary thought. What do you think, Peter?
We have and are certainly putting ourselves and the planet, and that's the entire planet, in a runaway situation. There's no question about that. And you're absolutely right. When we look at all of these changes, planetary changes, which we call climate change indicators, they're all absolutely at record high, but they're all increasing faster than they ever have. So the global temperature increase, which, as I say, is still almost 1.5 degrees C, that is accelerating. As James Hansen was the first one to advise, he was usually ahead of the others, I guess. But the scientific community now as a whole agrees that yes, the global warming is accelerating, but it's worse than that. We're actually already now, in last year, we were just above the very worst case scenario. That means that we are heating the planet at a rate that actually none of the scientists anticipated we could possibly do. The same thing applies to fossil fuel CO2 emissions, which of course is the cause of the whole thing. We mustn't forget about that. The scientists often do. They explain what's happening or what might be happening in various theories, but unfortunately, they don't very often remind us that the cause of everything is primarily burning fossil fuels for energy, which we have no need to do whatsoever. And if we continue to do it, the runaway situation will continue to run away faster. Now, you talk about runaway, that makes us think about feedback. Now, you've already mentioned the most important feedback, actually, which is the loss of albedo cooling of the Arctic summer sea ice, but also we're losing Antarctic cooling now because we're losing Antarctic sea ice, which goes around the Antarctic continent for quite an area. But it's even worse than that because in the summers now, the Antarctic is heating so much that the scientists there are seeing something they've never seen before, that is melt ponds on the Antarctic ice sheet continent. My final point will be on how absolutely extraordinary and terrifying the situation with regard to the Antarctic ice sheet is. I watch the climate indicators, and there's a little peninsula off the West Antarctic ice sheet. The West Antarctic ice sheet is about 25% smaller than the East Antarctic ice sheet. So mainly the Antarctic or East Antarctic. Occasionally, I'll see an increase in temperature of the West Antarctic. Very occasionally, I'll see that temperature track over into the East Antarctic a bit. I have never, ever seen what we're seeing now, which is the entire Antarctic ice sheet, not just above normal temperature, but far above its normal temperature. So yes, the scientists don't like to hear about Runaway, but we really need to talk about that because there's no question we are pushing the planet into a runaway situation. We have a lot of methane coming out of the planet right now. We have methane coming out of the wetlands in the Arctic and in the tropical wetlands. Right now, I just checked yesterday, we have permafrost, a large region of permafrost in the Arctic, emitting methane. We also have methane hydrate, that big terrifying fear we've held for a long, long time. We have methane hydrate now venting into the atmosphere from the Arctic seas, from the Arctic Sea and from the Laptev Sea. We are in big, bloody trouble. We are pushing the planet into runaway, irreversible situation under which we will have no control of whatsoever, no matter what we do. We got to get our fossil fuels fast.
Thank you so much for that clarion cry, Peter. And yes, indeed, it's very scary what you shared about the West Antarctic ice sheet. All of us are vulnerable to what happens when that melts. The sea level rise that's predicted is just so extreme. As it is, New York City is sinking and sea level is rising. Oh, a few millimeters a year. That adds up. Places within my country, like in Florida, Miami's already having nuisance flooding now without further ice melt. So the situation is dangerous and the situation is real. And thank you for letting us know that, yes, of course, we have to stop with the fossil fuels. Paul, would you bring us in on the clutch here on this topic?
Yes. So there was a BBC article recently talking about Thwaites Glacier, and the glacier is, massive glacier in Antarctica. It's retreating about half a mile per year, according to the article. Huge amount of retreat. If it went, it would raise global sea levels 2/3 of a meter, or about 2 feet at least. An interesting artifact from that glacier is a glacier labeled A23A. Okay, look up A23A. It's a flat table-like glacier that calved. What's interesting is it broke off about 30 years ago or so. It got stuck in place for many years, but it just started to move recently. And it seems to be stuck again, but not on the bottom. It's in this location where we have the Antarctic circumpolar current, the water current, are being split a bit by a rise in the seafloor. And that's causing a circular motion of water around that 100-mile wide rise. And that circular motion is has entrapped this vast ice shelf. So it's rotating on its spot about 15 degrees of angular rotation per day, counterclockwise. And it's been doing this for at least 4 years. Well, not 4 years, but the water has been circulating in this spot for 4 years. Some scientists put a buoy there and it's still there 4 years later, just circulating around this region. And now they have this A23 ice shelf there. So I thought that was just an interesting anecdote about what's happening in Antarctica. But let me talk about feedbacks, okay? Because feedbacks are, of course, vital. We talked about the albedo feedback causing polar temperature amplification. But once the poles are warming faster than lower latitudes, that completely changes the airflow. So the jet streams, which circle the region and help keep it cold, instead of being mostly zonal or west to east flowing, they slow down and they get wavy in the north-south direction. They become more meridional, which is change in the north-south direction. This is a vital feedback, because what it does is it brings cold air from lower latitudes up into the Arctic and Antarctic, respectively. It also brings cold air from the poles to lower latitudes. So it causes a huge amount of mixing and greatly accelerates the warming of the poles. And it also causes things like sudden stratospheric warmings, which just occurred in Antarctica, which then further breaks up the polar vortex, which is vital for isolating the poles and keeping them cold. So we have all of these different feedbacks underway from the jet streams and the airflow, and also, the ocean currents. The ocean currents are interesting because, as the Arctic in particular continues to warm from the albedo effect, from the jet stream effects, the going from zonal to meridional jet streams, and the warm air injected into the Arctic and cold air taken out, same thing in Antarctica, then what we're seeing is we get a change also in the ocean currents. The ocean currents, the AMOC in particular, we talk a lot about, and that's slowed significantly. That brings warm water to higher latitudes and keeps places like the UK much warmer than they'd be otherwise. And that's showing severe signs of slowing down. There's been a couple new papers on it this week. And there's also a very good paper that came out on what's called the GMOC, which we don't talk about so much, but that's the global meridional overturning circulation. And that includes both the AMOC in the northern hemisphere, and maybe call it the SMOC if you want, or it's the ocean currents in the southern hemisphere. So they're doing a similar behavior. There's significant slowing of the ocean currents in the southern hemisphere as well. So all of the whole, we need to talk about the whole climate system and keep all of these feedbacks in mind, because we're getting gut-wrenching changes right now to the climate system and all of these different elements of it.
Well, thank you so much for wrapping that up, Paul. I really found that interesting. And I have to say, I'm definitely going to check out A23A. I mean, I've not heard of this glacier, and I've definitely heard of the Thwaites and the Pine Glacier, but not that one. So thank you so much. You see, there's always something to learn. I really, really appreciate working with my team here, because I'm always learning. And we hope that you, our audience, also learned something here. If you did, let us know in the comments. What is it that you learned? And also, if you found it beneficial, and we hope you did, share this video with a friend, like and subscribe, click that notification bell so you always know when one of our videos comes out of the can and into your feed. And we look forward to seeing you next time at the Climate Emergency Forum.